A warm welcome to you all for the first in our series of RHEA Talk webinars. Firstly, let me introduce myself. I am John Bone. I'm the Chief Commercial Officer for RHEA Group, and I'll be your facilitator for today's session. So please, you're welcome to use the chat tool to pose any questions to our panel, which I will ask after an initial discussion that we will have. If you are targeting any of your question to a specific panel member, please be clear and explicit in your question of who that question is for. Talking of the panel, today I am joined by three distinguished panel members who are here to discuss the benefits and experiences of using concurrent design on a variety of projects. So let me please introduce the panel. Firstly, I have Sam Gerenay. Sam is RHEA's concurrent design expert, having worked in this field for more than 15 years. Sam has played a key role in the definition and evolution of the concurrent design processes and tools. Next to Sam, I have Ryko Broken, with over 20 years experience with the Netherlands MOD. Ryko is a change manager with the Defence Material Organisation, the DMO, and a user and now evangelist of the use of concurrent design in defence projects. Welcome, Ryko. And finally, last but by no means least, I am joined by Mark Roberts, an experienced lead consultant in large-scale projects across many different sectors, including security, energy, education and transport, while at RHEA and Atkins, and notably defence while at the UK MOD. So welcome, panel. For those of you not familiar with RHEA, we are a security and space engineering services company with over 600 employees across Europe and Canada. So RHEA's focus is to add value to our customers through the delivery of specific expertise, tools, and techniques. Today's discussion is focused on one of those techniques. So with that in mind, Sam, what is meant by concurrent design and how does it deliver benefit?
All right, thank you, John, and welcome to you all. It's exciting to have this first RHEA talk and especially to be able to talk about concurrent design. I apologize for having to wear a mask. Let's say Ryko, my distinguished colleague from the Dutch MOD, and I are sitting in the same room. So we have to take care of the corona and make sure that we protect ourselves. Having said that, a bit about concurrent design and what it is. Concurrent design is a methodology or a process that facilitates collaboration between experts in a multidisciplinary team to solve complex problems. That can be the design of a capability, like a spacecraft or a ship. It can also be used to design a process or a function. So it's very widely applicable to a wide range of subjects. So there's a lot of history in concurrent design, and it's a kind of concurrent engineering that has been around for a number of years. But since 1998, the European Space Agency has pioneered this methodology to improve the early phase design of space mission, or let's say future space mission design. And what we've done at RHEA is we've taken this methodology that we collaborated with the European Space Agency in the past, and we still do today, and also see whether we can apply it to the non-space business. So today we support the space industry, large and small corporations, but also non-space like shipbuilders, but also the Defense Material Organization, who's now using it to become smarter customers and to become better at specifying capability that they buy for their armed forces. And Ryko can speak to that a bit later. So how does it work in practice? What we do is we organize so-called concurrent design or work sessions where we put this whole team together and make sure that they have the proper mandate to make decisions while we're doing the work. We put them in a purpose-built room. Ryko and I are sitting in one of those rooms at the MOD today, one of the first rooms that we used, which in essence is a meeting room with tables set in a specific shape or form so that we can help the process work a bit better by being able to focus the energy and also the attention on specific people that are taking part in the discussion. What we do is we use system engineering principles to organize the work. So we start with a proper problem definition, We explore the solution space and try and match whether those solutions meet the requirements, but from all the perspectives that take place. And that's why you need all those experts in the room at every given time. So every work session, the whole team joins in and is able to influence the direction our solution goes. Again, that can be a capability. It can also be a process. Again, it's widely applicable. So the benefits that we see is that people can make decisions a lot faster than they were able to do before. So instead of approaching the problem one after the other, we parallelize a lot of the work, work on the basis of explicitly made assumptions or half-truths that you refine as you go along, and you come closer to the truth or to facts, and you don't have to wait for one of the experts to finalize all the work that is done before the next one can start working. So apart from bringing a whole team together in a properly documented, repeatable process, we also make sure that they do work together, and as they're doing work together, also influence each other to make the decisions that are necessary to make the right progress. And by doing so, we can do that 4 times faster with half the energy that is required to do it. So we spend only 50% of the time of engineers or experts as we did before by using concurrent design. And of course, we can also be supported by IT infrastructure that goes from tools like this, a web platform, to be able to also do this during COVID times, of course, because that's one of the challenges that we faced also this year, or let's say in the last year. But we also use tools to make sure that we can make our design and our problem explicit in a model so that we can do model-based system engineering collaboratively and hence make fact-based decisions. If I sort of give you a couple of examples of systems that we've done this on at the MOD, but also in other areas, we've applied it to space missions, of course, because a lot of our heritage comes from the European space industry together with ESA, but also on shipbuilding design, building and construction, and things like critical infrastructure. So a project that I'm supporting right now in Raiko's team is the design of a pump station that is responsible for transporting kerosene from location location A to location B. And of course, that is critical infrastructure in the infrastructure of NATO. So there you see that it's also, let's say, useful for that part.
Yeah.
Over to you, John.
Thanks, Sam. So Sam, you mentioned critical infrastructure. Mark, from your experience then, how can concurrent design be applied to critical infrastructure projects with complex requirements throughout the project lifecycle?
Thanks, John, and hello, everybody. Yes, so I have to say, my background is that I spent a lot of years flying airplanes. That makes me innately rather dull. So I therefore try and package things up into a 1 or 2 word phrase. And concurrent design to me means cohering and managing complexity. And so therefore it has a sort of natural linkage in a way with critical national infrastructure. What I'm going to do is I'm just going to do a very quick overview of the attributes as I see them of critical national infrastructure. I should say that these are attributes of any complex problem, with the exception that critical national infrastructure has to have around it a higher degree of assurance than perhaps you require elsewhere. And then I'm going to move on to using a live example that we're working on at the moment, which is a spaceport, because that sort of brings out all of the particular elements of complexity. So critical national infrastructure, by its very nature, is complex. It has inherent complexity. There is almost nowhere that you can look in the critical national infrastructure sectors and not find the sort of complexity that I'm talking about. But if you're talking about, for instance, physical design, then think of nuclear power stations, think of the transport sector. If you're talking about digital design, very obviously things like finance, but also things like emergency services, where you've got to get those designs right. And of course, and again, not unique, but ubiquitous to critical national infrastructure is understanding the intra and interdependencies. And one of the things that, of course, RHEA does most is space, and we know very well that actually for the UK, certainly for all of the other 12 critical national infrastructure sectors, space has provides services to those sectors, and although it's not necessarily acknowledged, actually those sectors have that dependency on space. So it's very important that when you're getting into the early stages of, and perhaps even upgrade stages, but certainly in the early stages of design, that you consider all of these aspects. I think another aspect of critical national infrastructure that's important is there are always numerous stakeholders. Very often they have different requirements. They potentially have conflicting requirements, and somehow that needs to be managed. They very often have different demands, and when complex programs are progressing, the time, the sequencing, and actually the project dependencies, not necessarily the output dependency, but the project dependency may drive different pressures into what you're trying to do. And one of the things, again, not entirely ubiquitous to the sectors, but close, is regulation. And the need to integrate regulation into your design, and the best time to do that is early. So getting the requirements right is critically important. And I tend to use, because I have a little bit of background in security, I tend to use security as an example of this. There is an adage in the security world that if you design security measures in at the outset, they'll cost X. If you design them in retrospectively, they will cost, pick your number, but the general conventional view is it's about 10 times X. So actually getting the requirements right at the early stage is really important. That said, things change. And therefore, there is a need to acknowledge the real world, that things might change, regulations might change, the requirements might change. So you need to be able to be agile to that change without necessarily massively disrupting your project or your program. And this is where I think the strength of CD comes in. Rather like, for those of you who are familiar with it, building information management systems, one version of the truth is really important. And if something changes, it is important that you don't have to unpick everything else to accommodate that change. So CD is, by its nature, able to track those changes, inform those changes, perhaps even automatically implement those interdependency changes so that you don't lose them. And what's really important here, particularly around very complex projects, is maintaining the golden thread of whatever the requirement was when you started at the front. Of course, I think Sam has mentioned it. From my perspective, the ability to keep multidisciplinary teams completely aligned is extremely important. And ultimately, what you're trying to do is optimize collaboration. So if I quickly move on to case studies. So RHEA is the program management organization looking after one of the Scottish vertical launch space sites. And I'm bringing that rather ambitiously into the realms of critical national infrastructure. Of course, it is not our choice whether it's critical national infrastructure, but from the point of view of design, which is the phase that we're in at the moment, I need to design for critical national infrastructure for compliance for reasons that I stated earlier. If we retrospectively go down that route, then actually it's going to cost us a lot more money and take a lot more time. So just to pick up on my core themes of complexity and stakeholders, the complexity is enormous. Infrastructure, the infrastructure around the site, although if you look at a map, it looks pretty simple. Actually, that infrastructure is incredibly complex. And particularly the connectivity of that infrastructure and how it relates to what the user does with it. There's also connectivity on-site, off-site, wires, radio, all sorts of different types of connectivity. And that has to be assured, otherwise our operation is not going to work. So it needs to be designed correctly. Concept of operations, again, critically important that we get the concept of operations right. This is a heavily regulated sector, or will be a heavily regulated sector. And concept of operations, or failure really of the concept of operations, is likely to result in a loss of license or no license being granted. So it's incredibly important that we get that right. And of course, overarching all of this is the fact that it's a business activity. So it needs to be within a cost envelope. Otherwise, it becomes non-competitive and the business will fail. And then I guess the top level point is regulation. The regulations are absolutely critically important, and they have a very, very significant influence on the way that we go around designing. I'll talk very briefly about stakeholders. I'll stick with the regulator theme. We have a number of regulators. It's not just one, so that's very inconvenient for us in a way, because some of their requirements are not exactly aligned. So again, we need to capture that complexity and make sure we get it right for all. Multiple users, our approach is to be available for multiple users. So that means that we're not designing for one, for example, launch provider, we're designing for many. The range, there are complexities around the way that you interact with the range, how the range interacts with the spaceport. And again, we need to capture that. A lot of that is in the communications, but also in the processes as well. And then there's a whole variety, I won't read them off, but there's a whole variety of launch stakeholders, including the air traffic related people, the people who are interested in the oceans, the emergency services, and other stakeholders that perhaps might not be so readily apparent. The environmentalists, we are going to be obliged, we are obliged to build environmentally friendly structures, environmentally friendly processes. So all of that says to me that we are going to be leaning heavily on a multidisciplinary teams, which is where CD comes in. And just to rattle around my list here, getting the requirements right, I've talked about that already, absolutely critical, but we do recognize that those requirements are going to change. So we need an ability to be able to react to those requirement changes in an agile way. For example, we may see a different user arrive, in which case there may be some subtle changes to requirements. Incredibly important that we get the communication right. We are dealing with local bodies, national bodies, all sorts of commercial organizations, sometimes international. So getting the communication to underpin the collaborative activity that is required is vitally important. And to enable that, we want to see the single version of the truth, the one version of the truth from which everybody can work. Why bother? Well, we need to optimize it. We need to optimize the site. We need to optimize the processes and the concept of operations. And we need to optimize the design and implementation of the project. So I've talked about the need for agile change process, very important. I've talked about the need to retain the golden thread. The golden thread is sometimes, in some respects, is commercial, but in other words, is technical, or in other situations is technical. And we need to get the cost and performance right for the business to work. And that means both the cost of the project, but also the cost of the site. So put simply, going back to my dozy aircrew view of the world, we have a lot of complexity and we need to efficiently manage it. John, over to you.
Thanks, Mark. Thanks. So Raiko, based on what you've heard so far, you chose concurrent design to use on your defense projects. Why did you choose concurrent design, and how is the DMO using the processes and tools associated with concurrent design?
Thank you, John. Let me share our CD journey with the members of this webinar. We chose concurrent design as a method to improve our procurement process. It's been one of our strategic goals for the past 6 years. It still is, because we want to make sure that our end users and the military personnel gets its equipment and material as quick as possible and as fittingly as possible. So we came across this method about 2.5 years ago, paid some visits to organizations that have been using it for a while, like ESA, the Dutch subsidiary in Noordwijk, and a private company. And then we managed to convince our board of directors that we should try this out. And what we've done so far is put our money where our mouth is. So one of the factors for success has been that we've been able to prove that it does work. And the biggest factor of success in that instance is sitting right next to me, and that is that you need to bring in the right expertise to teach your colleagues and your colleague employees what this new way of working looks like and what it is able to deliver for them. And it does add on all the formerly mentioned technological and procedural steps, but for me, in one word, it's been the icing on the cake so far, because it does, as a change manager, speaking as a change manager, it delivers, and it proves very quickly that it has the potential to add to our strategic goal, It involves the employees in an active manner. It doesn't only prescribe what they should do, but he invites them to participate, collaborate and participate. And it's proven a fun factor too. So I'm a very pleased customer so far. Does that answer your question enough, John?
That does. Thank you very much, Raiko. I mean, you mentioned things like factors to ensure success. I mean, Sam, are there any other factors that you can think of which come into play when you're looking to how you make concurrent design a successful activity?
I think, let's say, what is important is that you have support from the upper regions in an organization. That helps a lot, but that also is carried by the workforce. Of course, those, let's say, you can convince management that is something that can help them achieve their strategic goal. That doesn't necessarily mean the workforce will follow. So the approach that we typically take is that we go ahead and do it, and that we convince them as we go along that it helps them achieve their goals faster than they would without. And we start by explaining it to them, and we say, these are the things we can achieve. They don't believe us, of course, because they're all good project managers, good project engineers, so they are convinced that they're doing a good job, and they are already doing a good job. But what help them to achieve is that they can focus on one task instead of splitting up their time between 10 tasks that they have to do. So by putting CD in place, you ask them and their organization to allow them to focus on a specific task at hand. We time box it. We allow for the change that Mark has mentioned, so we are agile, and it is also fun for them, and they see results happening. They can actually, the comments that we get back after a couple of first CD sessions with a new team is that they say, we've never been able to make decisions at this fast pace. We're always stuck in emails, and we actually get to talk to people, and that is so much better than hiding in our office or hiding behind our workstation. So one, it's, let's say, having support from the top, that helps a lot. And then the other bit is actually not just talking about it, but doing it, and then by doing it, convincing the workforce that it actually helps them become better at what they do. Yeah.
Sure. And Mark, in your experience, success factors include?
Well, I think if I sort of draw back onto the spaceport example, actually the primary success factors are, I've talked about the one version of the truth thing, and I think that's very important. But actually, the most significant element or the most significant benefit of taking this approach is collaboration and the communication element. Because as Sam has just alluded, the alternatives are meetings, emails. Some people don't turn up at the the meeting, so therefore you have to repeat activity. And this, what this allows you to do is it enshrines collaboration, if you like, in the process of getting things done. So I think that's the most those are the most important parts. I think the maintenance of the requirements is also very, very important to me, particularly when you're working in a regulated environment, because it becomes evidence in a way for what you're doing with the regulator, rather than just displaying to the regulator what the product of your design looks like. You can actually give comfort to the regulator that you are considering their issues all the way through, and in a sense, you're a custodian of their issues through the CD approach.
Thanks, Mark. Just a question to the audience. I don't see any questions yet, so if you'd like to pose any questions to the panel, please use the chat box provided, and we can target your questions directly. Just another one for you, Raiko. So you mentioned that you feel that concurrent design is delivering to your business. How do you measure those benefits that it's delivering to the business? How is that demonstrated to you and to your peers and to your management?
By asking our customers how they experienced the added value of this tooling. As I said, we visited 2 other organizations, and we learned from them the results they were able to book on speeding up of the procurement process by a factor 4 to 3, ASA and the other company. a reduction of failures by 30%, re-engineering work, and a reduction of resources needed by 50%. And we're trying to measure those as well with what we call an intake process, where we figure out what our customer needs us to support him with. And then after CD study is concluded, we validate in the CD matter if we actually succeeded in achieving those results. And so far, I must say, without becoming too arrogant, that after just 2 years, 1.5 years of using CD, we've been able to reach the results ESA has reached after 10, 15, 20 years of using CDs, which we are very proud of. Because we're not as constant yet, because we need to train and educate most of our engineers. But I'm pretty confident that we're on a level where we speed up the process by a factor 2 to 3. Provides us a thorough base, together with the training plan that we have in mind to launch in May, to step up to the factor 4 that ESA is able to achieve. And that's only the time factor. Another important factor is the quality of the products and the collaboration aspect, or the interaction between our engineers, basically, which has been proven more difficult in the past. Communicating through email or the old-fashioned meetings is not very beneficial to have them share their information with each other. And that's where Sam comes in as a very helpful facilitator to make sure that everybody shares his bit of information, his data. So we work at one version of truth, as Mark said, which helps us to be a data-based and fact-based organization, which also meets the long-term requirement of our MOD. We just stated our long-term vision for 2035 and our ambition to become a data-driven, more innovative-based organization. And CD is a very helpful instrument in achieving that ambition as well.
Okay, thank you, Rick. I'm just looking. We do have some questions coming in now. So we have a question from Cyril. The question is: I understand concurrent design is about efficiency and speed. What are the applications that would not be possible at all without it? I mean, with traditional governments, even taking more time and resources. Oh no, Sam, could you give that one a go?
Let's see, I'm going to read it myself so I properly understand the question.
I think the question is about what applications would not be possible at all without it.
Yeah, I think that's a provocative question. I think most things without CD, but it will take you much longer, and the chances of failure are a lot higher, and especially that you have to fix things later on in the process. So what we're trying to do is to make sure that we have a lower failure rate when we actually, because we talk about design, but then there's also the implementation. So you put something on paper or in a digital form, you formulate what the problem really is, you refine it, you come up with multiple solutions, and one you actually go and implement. And what we do with CD is that we have a more of a first-time right approach, that you don't have to go back. And that also comes back to the things that Marcus said. You have multiple stakeholders that all weigh in and make sure that the solution and also the problem specification fits their needs and their, let's say, their goals as well. And we do also security by design. So the security aspect is immediately apart from the first day. That should not be forgotten, and that's really important. So to come back to the question, I think you can do it without CD, but it will be a lot harder if you do it without CD than with CD. I hope that answered the questions. Yeah.
I think so. Anything to add, Mark?
Well, only maybe an example. So one of the things that we're looking at...
Would you move your microphone a bit closer?
Sorry, rubbish microphone. one of the things that we're looking at the moment is design of the launch pads. And what we are trying to do is ensure that we don't design something into the launch pad that will prevent users using it, because they all do have different requirements. If we were to do that in a sort of person-drolic way, then we can expect that to take a very long time, and unpicking designs, moving things around. Whereas I think, Cyril, that the hope that I have concurrent design is that that process is just much quicker, and the reason why it's important to us that it is quick is that because we're actually in a fairly racy project to get to operations as quickly as we can. So that's in a sense is why we've brought CD into it. I hope that helps.
Same goes for the, if I can also add a bit to that, the same goes for the work that we do at the MOD. I mean, the projects that we do in RHEA's team are to be able to provide capability to people in the field when they need it. If they get that capability too late, they won't survive. So for them, it's of utmost important that they get it on time. And in order to get on time, we have to speed up. So being able to keep up with the world basically says that you have to become faster and more agile. So I come back to my answer. I think you can do everything, and we can do work in the traditional sense, more serial, hide behind our workstation. But the risk that we run is that in the case of the MOD, the people in the field get capability too late, and then they become obsolete themselves. And that is absolutely what we don't want. So it is important for the organization to have that agility and that velocity. Yeah.
Okay. I may add just one small remark to it, because this touches your prior question to me, John, how we measure successes. And this is a very good question if I interpret it well, touching upon the business case, because we are very pleased with the results we've been able to book so far, but we do need a point of reference. And that's all where data comes in. Data is king. And we measure our success by interviewing our customers. We would wish we could use data that's registered within our company to compare the amount of time, the amount of resources, as this person is asking rightfully, to compare the successes of CD with the traditional way, and how much capacity did we need to book results with CD compared to how many resources it requires in a traditional way. Now this is something we're working on right now, because we do need to stress also to this person that CD is a very intensive way of working. We've had some resource managers complaining about their employees needing 2 days off after a CD study, which is good because it is intensive, and therefore you work towards an end goal as a team. It's also a team building mechanism, because you work like a sports team. You put in a shared effort, so you share the results as well. But we are trying to measure it more data based, so we can compare that this intensive method requires more resources in the short run, but compared to the long traditional way of managing projects, the net benefit is still positive. So you need 2 people, you need someone, an engineer, SME, for 2 days a week for a CD study, which lasts 9 weeks, compared to the same engineer you would need for 9 months, a half day a week. So we are trying to make that comparison, but data is king. So in order to be able to answer that question honestly, the organization itself needs to be able to provide the data of the traditional way of managing projects, which is quite a challenge, I must say, even though we've been using Prince in name only for 20 years.
Right, thank you, Reiko. I think the next one is sort of targeted, well, at everybody, but maybe I would say to you, Reiko. So let me just take a look at this question from David. So, how has the COVID impacted your concurrent engineering process? Have you moved into more hybrid, online, offline process? And if so, any insights you can share? Obviously, you're sitting there with your masks on at the moment, so it has affected the process in some way. Can you elaborate, Raiko? Sorry to give you the
Sure.
question straight away after the last one.
No, I'm happy to elaborate. As I promised the participants to shed light on our CD journey so far within the MOD, so I'm happy to elaborate on this. Agility is, next to data, agility is also king, or maybe queen. And we've handled the COVID measures in an agile manner. And we've tried to uphold the principles of concurrent design, which are best met with physical attendance and collaboration, which Sam can then manage and facilitate the interaction. But of course, after the first COVID wave, we have worked out a hybrid way where we put together what we call the core team of a project of about 6 to 8 people, and have participants collaborate like we do right now in a remote way. With the tools we use are Skype for Business, and it is suboptimal. It's not the optimal way of using CD, especially not when you're first introducing it into your organization. You have to. I wanted to have the maximum spin-off of people like Sam and his fellow assistants, the system analysts. But it did prove results. Even in that hybrid way, we were able to support our customers in speeding up their project phases.
Okay, good. And you mentioned tools there, Raiko. I mean, Sam, do tools come into play here when you're looking at these offline, online hybrid solutions? So, of course, things like Skype, the type of tools we're using today.
Yeah, absolutely. You have to be able to share content, and that can come in many forms. We use a lot of PowerPoint presentations to assist talking about topics that are relevant, so that people that are listening in or participating from remote can follow the conversation without being there. At the MOD, we're also slowly introducing tools like CDP4, so our collaborative model-based system engineering tool, to also show the benefit there that instead of sending each other lengthy emails that contain lots of data that at the time you've sent it may already be outdated or is targeted to only one person or to two, and then misses the other part of the audience. But that we slowly bring in. So right now it's about showing that kind of tool can help, and it's not yet being a very active part of the process today, because to teach people how to use it. And in COVID, that has slowed us down a bit, because teaching also that kind of tooling is challenging, let's say, from remote. But we've done a fantastic job. I was worried that we would not be able to achieve our goals with the whole team that we have. Now, luckily, we had a team from a program that needed our support for a longer period of time. So there, we're supporting the Anti-Submarine Warfare Frigate, which is a replacement of an existing frigate for the Dutch Navy. And their program is so large that it's been split up into chunks to be able to target one topic like integrated logistics support or propulsion and energy subjects separately, because they are complex in their own right. They need a team of 30 people to reason about them. But with that team, we had a lot of traction. So they were used to sitting together. They already knew each other. They knew the method. They also knew us. And then it was easier to transition into this other mode of working, which was a lot of online presence as well. And it would be far more challenging to start now from scratch, trying to prove that it can work and trying to do it offline. Then I wonder, Raiko, if our success would have been the same. I doubt it.
Now, if I can add one insight for David, I'm willing to share that with him as a program manager. We've talked about the options we had after COVID first appeared, and we've submitted our board of directors 2 options: either postpone the studies or continue in a hybrid manner with a core team and remote participants, but accepting the suboptimal outcome, as I mentioned, of the method. Because my first challenge and primary goal is to prove this method is beneficial to our DMO organization as well. And that's that has worked out very well. We've submitted these options to them. They have accepted it. So then they can never blame us for proving to be suboptimal.
Yeah.
Mm.
Still, then it was a pretty good result. I think
it's been like it went further than I could have ever hoped for. Let's say the success we.
It was a journey for you as well, wasn't it?
Absolutely, yeah. But I think it's for everybody in the world a bit of a journey right now. So, but also in that respect, yeah. And kudos to everybody in the MOD willing to do it in this way as well. It's not only let's say Raiko and the people that work for him directly, like myself, facilitating or rolling out concurrent design. It's also for every one of those studies, those 30 engineers that sit in the room with us and have to work and think hard and also step up their game, because they have to. It's not that they don't know what they're doing, far from it, but they have to be able to willing to share based on many unknowns and being open about that, and that's challenging. So the fact that they managed to do that, and also in COVID times, is impressive.
And Mark, any experiences that you can draw on from the particularly the spaceport case study that you mentioned? Because you've got a situation there where I guess you've got different expertise in different companies dotted around the whole of the UK, in this case, maybe even Europe, in terms of how that information is shared.
Yeah,
for the concurrent design.
Further afield than that, actually, John. Yeah, we are literally all over the world. I think the sort of philosophical approach to this is make what you do very focused. So I don't want to sort of mix concepts here, but we tend to sprint around gathering data. So we make our interactions, the team interactions, very focused. It is about one thing. Sometimes we split something into two parts so that we get it done in an hour, then move on possibly the next day to the next thing. So we if you like, we try and hybrid to go back to the question. We try and sort of make it work by being focused. That's driven, that's been driven into our processes by the fact that we can't actually meet up. The important point is that probably we wouldn't be able to meet up anyway with some of those people, because not everybody's going to get on an aeroplane to fly to sunny Scotland to put their input in. So actually, to a degree, I'm ex-MOD. I used to be one of the heads of capability in MOD in Whitehall, and one of my programs was a very significant American program. Frankly, we couldn't sit down weekly with those people, so that's an enduring aspect of programmatics like this anyway.
Okay, thanks, Mark. We're running out of questions, so please, if you've got some more questions, please send them in. Okay, we have a question from Clivio. Talking about indicators, as per your experience using concurrent design, how much can you reduce the project lifecycle duration? So perhaps, Sam, if you'd like to start based on your experience, 15 years experience, my goodness, of using, I know, of using concurrent design, maybe in other customers as well, what they felt. Raiko mentioned European Space Agency, for example.
Yeah. So the benchmark that we use a lot, also because it's in the public domain, is the one of the European Space Agency. And there, also in the time I worked there in the concurrent design facility for roughly 11 years, being involved in that team. And there we measured, actually, that we were able to speed up with a factor of 4. So the feasibility of a space mission would take anywhere between 6 to 9 months, and now they do that in 4 to 8 weeks. Using concurrent design and putting everybody together. So that's a factor of 4 of that part of the design cycle, right? So it's not the whole design cycle, but it's the feasibility work. At the Dutch MOD right now, we are coming close to those numbers, and it depends a bit on the team and the perception that a project manager has, how long it would take without CD. And that's one of the things that Raiko mentioned. We have an interview where we establish what the goals are of the concurrent design study or activity, how many sessions we will do, who we need to involve, and then we also ask the question, So in your normal way of working, if you were just to do it without CD, how much time do you think it would take? And then I mean total duration, not the amount of effort.
Yeah.
And then they give us a number, but that's of course not measuring, right? That's giving a projection or an opinion about what it would take, given all the constraints that they have within the organization. And then we run the study and then we compare. And for some, we are twice as fast, sometimes 4 times faster, sometimes even 10 times faster, because we get that focus. If I look at other industries, for instance, we've done work with a dairy company, and there we were able to speed up with 30%. So I think it's fair to say, and in the year that we worked with them, right? So we did a number of projects that were sort of following up one from the other. There we managed to decrease the overall time by 30% or lapse time. So I think it's fair to say that with the experience at the MOD ranging between 2, 4, sometimes 10, which I think is a bit of an outliner, if you will. The 200 plus studies that European Space Agency has done in their facility, reaching a factor 4. I think it's fair to say that anywhere between 2 and 4 is achievable in a short time. And then a bit of padding on my own shoulders if you bring in the right experts, right? So RHEA relies on all the lessons that we've learned by doing this in the last, for me, 15 years, which means that I know what not to do, but I also learn every day, because it depends a bit on the organization that you work in, what works best for them. So we have a documented process that we can repeat, but of course we adapt it to the needs of the organization.
Sure.
But yeah, I would say anywhere between 2 and 4 is easily, quote unquote, easily achievable.
So Raiko, you mentioned that you're getting to those numbers, or close to those numbers achieved by ESA after 18 months. Do you have an ultimate goal?
Yeah, to meet again in 5 years' time when Sam will be completely white-haired, to see how much effort. Now to see how much our end users have actually benefited from a first-time right design, because we're focusing on the project phases now.
Yeah.
But projects are only a means to an end. We wish to deliver the best products to our end users, and the proof of that pudding is in the eating of those products after delivery. And given a general lead time, mean time between requirement and delivery, that's about 5 years for larger military systems.
Right.
That's why I mentioned to meet again in 5 years to see how much rework we have saved, to see how much better our PORs, our programs of requirements, have proven to be for our suppliers to deliver the products first time right. Because that's the ultimate goal that I'm aiming to achieve. We're
getting
here
it right first time.
We're here to support the project managers in a fun way, in a very methodological way, in a beneficial way. But at the end, what counts is to get the right material to our end users.
Okay, thank you, guys. So we do have another question from Viral. So I think possibly target a little bit more again towards Sam, but anybody can contribute. So I'll ask Sam first. What does the future of concurrent design look like? Artificial intelligence, virtual reality, augmented reality, perhaps?
Absolutely.
So I'll pass this to you first, Sam, and then we can continue.
All of those things come into play. So as technology progresses, of course, we embrace things that can help us do our work a bit better. I know, for instance, at the European Space Agency, work is ongoing to actually infuse the use of augmented and virtual reality in the whole process to get better immersion in what it means to be that solution from all the designers or all the engineers that contribute to a future space mission. And because now you can build AR and VR based on regular computing power, so you don't need very fancy servers, you need good engineers to then develop those applications. That becomes part of what you can do. And the same goes for AI. At RHEA, we're collaborating with a number of organizations to get AI in the mix to actually help engineers come to better solutions sooner. So the team will come up with an architecture of a space mission or of a ship, and then you have a bit of AI that actually, at the same time, tries to figure out if there are potentially better solution architectures. So then a team can be creative, come up with a potential solution, and the computer or the AI isn't as creative, but it is far better at doing a lot of iterations over potential differences in the architectures and feeds that back into the team. And not only in RHEA we're doing this kind of work. I know of, let's say, colleagues in universities that are also developing what they call design assistants to actually give proper feedback to engineers on the value of the design that they're creating at that point in time. So a lot of work is ongoing in industry to add all of that smart capability, AI, AR, VR, data analytics to concurrent design to become even better and faster and basically even more fact-based than we are today. I think we're already very much fact-based, but we can just add on to it a lot more.
Would anybody like to add to that, Mark, Raiko? It's more of a Sam question.
One piece of advice. It's good to evolve and to add AI and VR to the method of concurrent design, but to also stick to the core of your principles, which are very, very strong, and they are based on the physical presence and participation of people, being directed by a team lead, facilitator, and a system analyst, which captures all the data. I think that's your fundament. Don't lose those fundamentals.
Yeah, I think you make a valid point.
They're successful, they're valuable, they're fun, and they also add to the next question of the team approach. If I can continue.
So I was going to ask you that one directly. So go ahead, Raiko.
I'm sorry, I just gave this pass to myself. That is why I'm so keen on keeping those core principles of CD, because we've seen that, I've experienced and also got feedback from the participants that it is a very, very beneficial factor in team building. And we all know that you run to, when you design a team or put together a team, a project team, some people know each other, some don't, some like each other, some dislike each other. You have to go through these phases of forming, storming, norming, performing. And what we can see is almost clockwise is that after each session, we've evolved to the next phase of team building. So that's a very, very strong and beneficial spin-off of concurrent design into the team collaboration that I've witnessed and also heard from participants after studies. They thought how much fun it was and how much more acceptance there was for each other's point of view, because it's data driven, and some make sure it's data driven and not an assumption driven.
Yeah, also goes back to the previous topic, John, about, let's say, how can you benefit from AI and AR, VR? And it's the same with platforms like CDP4, right? That we use to support the process. These are things to support, but not replace. So that's something that you have to bear in mind. You need stakeholders that have an opinion based on fact, preferably, or they should have it based on fact. You need their points of view. You need to do analysis and work. But it's the brain power of those people that you bring together. And I think at this point in time, we should not make the mistake that we can think we can replace those engineers with AI. We might get there somewhere, but we're not there today. Doesn't mean we don't have to work on it, but I don't think Siri will be able to help us design a frigate. Not just yet.
That would be nice. Siri, design me a frigate. I'm with you. I can't see that happening. Okay, so we have another question coming in. Well, thanks to Gwendolyn for that question. Let's see. So from Jacksu, asking as a member of RHEA working at ESA. So working for ESA, how would you suggest to improve the concurrent design methodology or change it when there are multiple contractors involved? Oh, really? Very specific question. The outcome efficiency techniques of others might be outdated or not in line with yours. As RHEA, how do you approach encountering it? I don't know. Who wants to go first on this one?
I'll take a try at it.
Thanks, Sam.
At RHEA, we have let's say, I think what we've learned from the European Space Agency. We've pioneered it in Europe at least, and also in ESA. Concurrent design has evolved over the years, and the same thing happens in other places. You don't sit still, and there is value in the things that we've learned over the years, and those we've documented, so that we have a repeatable process. But that doesn't mean that what we wrote down 5 or 10 years ago is still what we do today. You live and you learn, and you improve on what you do. What we do at the MOD right now is that we train up people so that they can also do things, but it's not so rigid that you cannot deviate slightly, because every team leader that I know, also in our team, in the team at ESA, and in other places that we've either worked for to teach them how, or that we've collaborated with because they've built up their own capability over the years, people have their own style. My style of standing in front of a team is not the same as people in the ESA CDF, but that doesn't make mine better or theirs worse or the other way around. It's just slightly different. What I do think is important is the thing that, or let's say what Raiko just mentioned, there are core values in CD that I think you have to be aware of and you should promote. And in the, let's say, we call those rules of engagement. There are rules to doing CD, and they're not super complicated. It is you time box your problem, you make sure that you can meet together to have work sessions where it's allowed to do something else. You do work, but you are there to participate with the team. So it's those core values that I think are important. And some people do it slightly differently, but that should not be a problem. And the way that we make sure that we keep on learning and evolving is by having interaction with other organizations or customers, in this case, the Dutch MOD. I also learn from working with the people in this team, but we also go to conferences and we share ideas on what we've learned in the past. So we're not in isolation, we are part of a larger community, and we exchange ideas on how things are done, and we're open about it. And that's also visible in the software that we write to support it, right? Also that we're open about. It's open source, so we even give it away, and it's visible to everybody what's on the inside. Michael?
Yeah, can I add a short remark to that, John? Because it's a very
Sure.
sublime question. It's coming from ASA. So I admire those people there, those engineers. I think there are two ways if you want to avoid this this issue. One is use knockout criteria in your contracting process, that you request that your suppliers use a certain method. And the other one is the one that I prefer, which we also promote as some said in our, as we call it, ecosystem. We have an ecosystem of MOD, the knowledge institutes, and the suppliers, our strategic suppliers, the industry, in which we more and more promote concurrent design as a tool that's proven beneficial and helpful to us, to MOD. And we also invite them to participate in several sessions where they are allowed to, after their contract has already been assigned to them. So we're also teaching and promoting and teaching the use of method within our ecosystem to make sure that we all we create like a level playing field in terms of approaching a project and helping speed up the project towards the end goal, as I mentioned before, to get a better result for end users. And I prefer the second option, but in the end, you might also opt for the first option, to use knockout criteria. To make sure that your supplier gets the product delivered the first time right.
So we've just got 1 minute left for one last question, which is probably a complex one, but let's try it straight to you, Raiko. When you first introduced concurrent design, how did you manage resistance to change? I mean, in general, senior stakeholders are used to their methodologies, and innovation tends to disrupt their consolidated beliefs. I face this issue as a program manager every time I propose a methodology changes, such as collaboration tools or process optimizations. Eventually, I reach the target, but it takes too long, in my opinion, and many opportunities are lost in the meantime. So,
very brief.
A few seconds. As a
Yeah, very
change,
briefly, we've mentioned them before. Make sure there's a compelling reason to change, that it's within your strategic goals, which it was, speed up the procurement process. Then invite your senior stakeholders firsthand to see what it looks like and how it works, what the results are that can be achieved, and what conditions are that need to be met in order to perform like ASA did. And then make sure you get the right expertise on board to show results bottom up to your employees. And that's the best way to invite them to participate and contribute to the shared results. So there's a top-down approach and there's a bottom-up approach. And I think some mentioned it as well 50 minutes ago. So if you recorded it, Mr. I don't know who asked the question, can rewind it.
So I'm going to have to wrap up now, but 1 minute over. Apologies for that. But many thanks to you all for your time today. If you need more information, please visit our website, www.rheagroup.com, or email info@rheagroup.com. And we hope to see you on future RHEA talks in the future. So from myself and the panel, thanks very much for your time, and goodbye.
Bye, thank you.
5 years.